I'm going to be showing you how exactly a calorimeter works. So the first step for any experiment is to make sure that you are properly covered and are wearing the right attire. So for experiments, you should be wearing a lab coat, gloves, goggles, long pants, and closed-toed shoes just to make sure that none of the chemicals get on any skin or in your eyes. So we're going to go ahead and set up the calorimeter, and then we'll go into how this can be used and stuff like that. I have a certain amount of volume in this cup. We're going to go ahead and transfer that into one of the cups that we will be using in our calorimeter. And we're going to pretend that these two cups here are styrofoam cups. And the reason we use styrofoam cups is because it helps create more insulation in the system. If the system is producing energy, we want that to be picked up from the surrounding water inside the calorimeter rather than dispersing into the atmosphere, because then we can't analyze that. And the same goes for if the system is endothermic and absorbs energy, we want it to be absorbed from the heat of the surrounding water in the calorimeter rather than the outside atmosphere. So we're going to be using this safety pin. We're going to drop that into the system, and usually you would just place this on like a magnet table that would stir it. That's a magnet, and so realistically this would spin on the bottom, and that would make the bobby pin inside stir as well at a constant rate. We're going to use a stir bar just to make sure that there is an even and constant stirring going on within the system, because then it's going to, it would affect how soon certain reactions occur. And put the cap on this to make sure that as little heat is lost or absorbed from the outside. This is just going to make sure that it's more of a closed system. And I've got my handy dandy thermometer. So I'm just going to stick that in this straw right here and kind of assume that it's going straight into the system. What we would do in a calorimeter experiment is that we would first add one reactant into the system, kind of let that disperse throughout, and make sure that we plot that information. And then after a little while we would add our second reactant, and trying to close that lid again as soon as possible to make sure it's going to be tracked and observed. So this calorimeter is going to be set up to the Vernier graphical analysis, and what that's going to do is it's going to analyze the temperature change of the surroundings rather than the system itself. With that, we're able to see the change in temperature of the surroundings is going to be equal to the change in temperature of the system, since it is a closed system. So one of the main uses for a calorimeter experiment is to analyze the change in temperature of a reaction. And so if we are able to see how much the temperature changes, we can then analyze how much energy is consumed or lost in that chemical reaction.